So in our previous lesson, we have already talked about intervals. So just starting from that concept, we are going to talk about domain, codomain, and range of a function. So let's get started. So you people are already familiar with functions and you know that it's a special type of relation. And for relation, you know the concept of domain and range, etc. So let's just start building up from that concept. Look at this arrow diagram here. You know that you can actually represent the possible ordered pairs like this. Now, if you look at the first components and you jot them down, you basically get the domain. Similarly, if you look at the second components and jot them down together, you will actually get the range. So if you look at it in totality, you will understand that the domain is nothing but a list of first components, whereas the range is the list of second components. Now, it might look very similar to what we have learned in relations, which it is, but since it's a special type of a relation, so we have some more things about domain and range of a function. So let's see what they are. So look at this one. So suppose you're considering any function f from a to b. So basically the first set is the domain and the second set is called the codomain. Now all of a sudden you knew that okay, the first component came from the first set. So why is it the entire first set? So remember the definition of a function. Each and everything should have a specific output. So all the possible elements should have an output. So if you collect the inputs, it should cover the entire A. So definitely if you look at the range here, f of A, which is the image of the first set, that will be the collection of all possible fx where x belongs to A. This is called the range. So you actually jot down all the outputs, you get the range. Clearly you understand that this will be a subset of the codomain. Now, there's something which is very important. If you see examples, you will actually understand the concept better. So look at the most basic things to start with arrow diagrams. So the domain is AB, which is very obvious. We are going to take the entire first set. The codomain is the second set. But if you look at the list of outputs, you will only see one. So that is why you can clearly see that the range is actually a subset of the codomain. For this one, the domain and codomain are the same and the range will be 1, 2. And here you can see that the codomain and the range are same. So you can have a codomain which is a perfect superset of the range, whereas they can be equal as well. So let's apply as we have seen arrow diagrams. So I'm going to go ahead and show you some general examples as well. F is from n to n, fx equals to x squared. The first thing that comes to your mind is domain. So what kind of possible x's or inputs we can have so that you can have a definite image going on. So if you actually understand this, if you just put any natural value as x, you will definitely get a value. So the domain is x. The codomain is also n, but look at the range. So if you look at the inputs like 1, 2, 3, 4, etc., they will actually give you the outputs like 1 square, 2 square, 3 square, and all those things. So the range will be the set of all possible squares, which is of the form 1, 4, 9, 16, and all these things. So it will just go on. So that's why I have given this dot here, so that you understand. So for these kind of things where the function is given as a very general example or general rule, so this is how you can find out domain, codomain, and range. So let's take another example. So f from R to R, fx equals to root over 9 minus x squared. So previously I have said that we have to jot down all possible x's for which the value is defined. So maybe sometimes you can get lost that I don't know what kind of inputs it can have. Then look at the function itself. Do you see the square root sign? You know that the square root will be defined if the quantity under the square root is non-negative. So this is what we have taken. So x squared minus 9 is non-negative. So this is actually less than equals to 0. We can factorize it. And from this inequality, we can say that x belongs to minus 3, 3. They are included because we have this equality going on. So this is the domain. In the previous video, I talked to you about intervals, and you can see how beautifully we can use interval to actually write down this domain and range. Now look at the range here. It's very important that you understand that sometimes we see what kind of inputs it has. Now if you look at this root over 9 minus x squared, you will understand that this will be maximum when x square is minimum, which is 0. All right, so the maximum value of f can be 3. If you look at the minimum value, it is minimum when x square is maximum. Now, if you look at the inputs, x is maximum 3 or minus 3 on this side, so x square will be maximum for 9. So minimum of f is 0. So it should lie between all the inputs, whatever you take, the output should lie between 0 and 3. So that is why this is the range. So I hope you understand the concept of domain, codomain, and range, and how they are special for functions, and also see how we can find them out for arrow diagrams as well as general definitions. So in the next video, we are going to talk about algebra functions. So stay tuned.